One. Hello and welcome back to Calculus 2. The next section is 6.5, length of the curve, also known as arc length. We know how to calculate distance between 2 points using straight line. Just use distance formula. Very simple. But what happens if that line is curved and you can't straighten it? For instance, this cord, right, for my cell phone charger is a curved line. Now, it's in a 3D, so I can stretch it actually and then use the ruler to measure its length. And it's 3 feet, say, right? But now imagine the same cord made out of the metal that I can stretch, right, and measure. Is there a way, mathematical way, in 2D to do that? Because there is going to be one for 3D in Calc 3 as well. And the answer is obviously yes, because we have the section about it. So, if we see a straight line that stretches from point A, B to CD, you can easily use the distance formula, square root of C minus A squared plus D minus B squared, and that will give you a number which is the distance. But then, say you have a curve, some kind of f of x, and you want to figure out what is the distance from A to B. You are looking for the length of the pink portion, right? That's what you're looking for. So there is a mathematical formula which is very easy to derive using Pythagorean theorem. What we do is we cut the small portion, welcome dx, right? And in that small portion, if you blow up this piece, you will see a curve there, which we approximate by the straight line. And then this part here would be our delta x, delta y, and this is L. So we know that delta x squared plus delta y squared is that L squared that we are looking for. So how much is L? L is going to be the square root of delta x squared plus delta y squared. And the little trick that we can do is we can factor out dx squared. Now, when you factor out dx squared, you are left with 1 plus dy over dx squared. And then this dx can escape the root, and we have delta x times the square root of 1 plus delta y over delta x squared. Now remember that this L was approximation. If we make these delta x's infinitely small and we fit infinitely many of them between A and B, we get the standard conversion into an integral, where this delta x becomes dx and this delta y over dx, delta x becomes a regular derivative. So it's very quick to see that sum of all of these small parts, this becomes integral a to b square root 1 plus f prime squared dx. This formula is your length of the curve. So arc length. You also have the one in dy, so L equals c to the square root of 1 plus f prime of y squared dy. Rarely used, but still used. So let's say you decide to tutor, right, a kid in 8th grade, right, $50 an hour, because you can, you know math, right? You own the world. And they have to compute the length between 2 points, right, using the distance formula. You show them the distance formula, you do all this work, they calculate, and then the kid says why. Okay, let's see why. You immediately wipe out the integral, right? That's it. Put the integral on the table. So the simplest problem would be to compute the length of a linear line, right? So let's say you have the line like this. Y equals 2x plus 1. And you want to compute that on 0 to 3. Clearly, you can compute a function at 0 to get xy, compute function at 3 to get xy, and hit it with a distance formula. That's what normal people would do. But then we're in calculus, right? Which means we're above normal. So what we do is we set up the integral for this thing because we can. The length of the line will be from 0 to 3, square root of 1 plus the derivative of this function y prime is just 2 squared dx. So the answer is clearly 3 root 5. Right? So this would be the simplest possible exercise. All you do is you follow the formula, you take the derivative of the function, you square it, plug everything in, and compute the integral. Now hopefully you see that you have this situation of 1 plus derivative under the square root. So that might lead to some scarier situations, right? We have to see which scarier situations. But integration for this particular section could be tricky, especially because you only know one technique, right? So remember what I said for the first exam, right? Your only technique for integration is U substitution. So if it's not a basic integral, it's a U sub integral. So in that respect, Chapter 6 exam 1, is a joke. But then you offset that with learning the formulas from each section, right? Figuring out is a disk method, is a shell method, is a wash method, right? So those are the Calc2 decisions that you make on Chapter 6 exam. But the integrals are either basic or U sub. So let's take a look at some of the homework. By the way, the lecture portion is done. You have the formula for length. That's what you have to learn, right? That's your Calc 2. And now we just do Calc 1 for the rest of the class, because you have to take one derivative, plug that in the formula that you memorized, and then integrate, right? So from this point on, the rest of the section is Calc 1. The next example, yeah, this book is amazing. They go linear problem, linear problem, linear problem, and then exponentials. There's no mid ground, right? One thing that I have to point out, guys, when you are solving homework, whether it's online or in the textbook, observe this symbol. This symbol says you will not be able to integrate. You have to use technology. This is where Mathematica, Wolfram Alpha calculators and things kick in, okay? Because the integral that you get, you have to do approximations, you have to do something, right? Because it's not going to be something that you can just solve with the methods that you are used to. So this symbol shows up a lot in chapter 6 because you can't integrate yet. You learn how to integrate in chapter. You're much better in chapter 6 and 7 are swapped. You learn methods of integration and then you apply integrals. But in their infinite wisdom, this is how they do it. So here it is again and again, right? So make sure that your technology is ready for you to compute these things. Let's solve problem 11 because we can. Probably you already noticed that I'm not solving examples that are done in a textbook. I'm making up my own and I'm picking stuff from homework. You guys all know all of the letters and numbers and you can read those if you're interested in extra examples, right? Those are worked out. There's no need for me to talk over them. You can read the book. So problem 11 says that the function is y equals 1/3 x to the 3/2 on 0 to 60. That's the problem. And we really don't need to draw anything here in this because it's quite clear what we're doing. To find the length of the curve between 0 and 60, and there's just one formula. You don't have to worry about stretching dx or dy or anything like that. It's just the formula is given in terms of x. It's dx and you're done. It's kind of simple, right? So what's the derivative? What's the y prime? We need that. Copy the constant, drop down the exponent, subtract 1, which is square root of x over 2, right? That's what it is. So that's our derivative. The length of the curve is the integral 0 to 60, square root of 1 plus, and the great killer here is to remember to square. All right? That's the one that really kills the grade. So that's going to kill the square root. And we have 1 plus what? Very good. Dx. Yeah, gotta be quicker with those things. How do I integrate? What should I do? U sub. You look at this integral and you say, oh, if all of this was just like one thing, then I can do it, right? Which is u equals 1 plus x over 4. du equals 1/4 dx. I need that 1/4. So let's put 1/4 and offset by 4. So 4 integral square root of u du. I need to change the limits. I don't want to go back to x because definite integral I have it, just change it now and don't worry about anything. So plug in 0, we get 1. Plug in 60. 60 divided by 4 is 15 plus 1 is 16. Very quick. So 4 times u to the 3/2 divided by 3 and then put the half up there. From 1 to 16. I don't have to go back to x because I changed limits to u. So just compute. I have 8/3, 16 to 3/2 minus 1 to 3/2, which is 8/3. Square root of 16 is 4, so 4/3 minus 1. 4 cubed is, very good, minus 1. 63 divided by 3. Nice. And then times 8. Perfect. Or you can use the calculator. Wow. Did I? We'll see. I can. Where? Cool. All right. Shall we do some algebra? Yeah, let's. Another problem, 14. Y equals x to the 3/2 over 3 minus x to the 1/2 on 4 to 16. This is one of those. Remember? The algebra bad ones? Yeah. Well, the units were not mentioned, so you don't have to put units. Could be inches, could be centimeters, right? Because it's length. What happened?
That's not what I meant.
What do you mean?
Like, is there like a point where you're like, I know that you can do those calculations and you don't bother? Like, I know you can multiply.
But how do you get? You need to get the value.
All right.
The value is yeah.
All right.
Because that's going to be 168 miles between,
I know.
right?
All right.
Okay, ready? Did you already get the derivative?
Yeah.
Perfect. What is it?
X to the 1/2 over 2 minus 1 over 2 squared of x.
The derivative is root x over 2 minus 1 over 2 root x. Nice. Ready? Length of the curve is the integral 4 to 16. Square root of 1 plus open parenthesis root x over 2 minus 1 over 2 root x dx. Yes, I was texting you. Good. How do we integrate this? It's tricky. We have to do the algebra first. We have to square the thing, see what happens, right? Awesome. Square the first one, we get x over 4. And then we have the middle term. And then you multiply them. Square root of x and square root of x cancel. So, do you see that it's a negative half? You have 2 times a times b. Right, 2ab is the middle term. dies, you just have a half. And it's negative. And then plus 1 over 4x. Now you see that you don't need these parentheses, so we'll get rid of those. And then you see that you have like terms that you can add. So the next step is integral 4 to 16 square root of x over 4 plus 1/2 plus 1 over 4x dx. So I need to make sure you're all caught up, because this is one of those moments when you put the pencils on the desk and stare until you see stuff. So catch up with writing, and when you caught up, put the pencil on the desk. Ready? Look, put the pencils on the desk. This came from here. This one is the same as that one, except for the sign. Do we all see that? So that means that this one compresses into that one with a minus sign. Hello, algebra. From scratch. This one came from here by simply squaring it out. You can compress this one into that, right? Using completing the square, right? You go back. So this one came from here. Now, what you realize is that this one and the one in the middle have the same members, except the sign of the middle term is different. They have same numbers. If you know your formulas from algebra, you know that a plus b squared is a squared plus 2ab plus b squared, which was expanding, right? And you also know that a minus b, hopefully, is a squared minus 2ab plus b squared. You see that? What's different? The sign in the middle is different, which creates a different sign here, which is the trick we're using. So what I'm going to do here is I'm going to simply write this as the integral 4 to 16 square root of, and I'm going to go back up and look and write root x over 2 plus 1 over 2 root x everything squared dx. So I'm using the same thing from here, except I'm changing the middle sign, and that's because these two are the same. It's just the middle sign is off. And we see that from formulas in algebra. It's a really neat trick. Does that help? Hell yes. Square root dies to that square. It couldn't happen before because of plus 1. All right? Plus 1 was in a way. But when you do this, right, expansion, and you add this 1 and the negative half, the negative half becomes, because you added 1, positive half, which changes the middle sign, and that 1 was consumed. So now these things die, and you can just integrate. So we have 4 to 16. We have 1/2 x to the positive half. We need to integrate now. Plus 1/2 x to the negative 1/2 dx. And now you integrate, the rest is cheap. 1/2 x to the 3/2 over 3, put the 2 immediately up there, plus another half. You can factor half out if it bothers you. X to the 1/2 over 1/2. 2's die. And what do you have? You have 1/3, 16 to the 3/2 plus square root of 16 minus 1/3, 4 to the 3/2 minus square root of 4. Right, when you do the f of b minus f of a. So now square root of 16 is 4 times 3 is 64 over 3 plus 4 minus, again, square root of this is 2 to 8 8/3 minus 2, these things. So 64 minus 8 gives you 56 over 3. 5 plus 6 is 11. It's not divisible by 3. And then plus 2, which is 6, which means 62 over 3 at the end, I hope. Bueno, what time do we end? 9:50? Oh, great, we have time. 12:50. We ended at noon.
Oh, let's get some pizza or something. There you go.
Let's. Oh yeah, thank you. All right, guys, so work on this. 3 ln x minus x squared over 24 on 1 to 6. You know the formula, you plug everything in. What's y prime? Three over x.
Well, yeah, no, I was right though. Technically, right? Yeah. So what's so 12? I don't think I was right.
All right. We don't have class till Monday, but you have homework and the labs will be uploaded, say Friday or Saturday. That means you download at least lab 1, work on first whatever amount of problems are covered in class, so that on either Monday or Wednesday, whenever we have time, you can have your first lab time to work on these concepts. Which way you're going to break for your labs is up to you. Maybe you want to do it by row, either way 6, a group of 5, group of 5, group of 4, group of 4, group of 4, and then if you guys are, that's it, then group of 5 here, whatever. Try to have 4 or 5 people in a lab group. 3 gets to be tricky if one person doesn't participate or quits or something, right? 4 and 5 is the best. Do your labs on your own and then bring them solved to class and then argue answers, and don't ask me stuff, it's graded material, so I'll just do formula. I can restate the problem, but I will not be telling you whether it's right, and I will not be telling you how to do it. Right? Because it's graded material. I can't do anything about that. Nothing. Yeah, that's it. So labs are uploaded in the labs folder, will be uploaded in the labs folder where the syllabus is in Lansden. No individual labs at all. I sent that. So make sure you have at least 3 or 4 names on that thing. And don't make up. I have a class roster. Don't hand in. You know, we have, you know, Joe who signed up for a class, and I have a Mickey and Goofy. Yeah. That happened once. A student actually tried to slide in the lab. We stayed furious. I graded the whole thing. And then I started plugging in the grade, and then the 2 makeup names are not from the roster. Like at that point, you know. That needs to be in the form of a meme. Actually, it is already in the form of a meme. You don't need to write it.
I love that.
That happened on this chair, right?
Yeah, yes, right there.
Yeah, I think it was.
I'll never forget him arguing with the class.
Are you guys doing this problem or missing one? Where is my behavior direction? I've used it in the past.
Yeah. Too many times.
Twice only on you. On him twice, yeah. Haven't used the other one yet. One of that. See that aim? Put it here in a good one. Yeah, you actually need to figure out which it's a very limited amount of examples. Because, again, your density around the fact that you don't have any of the integration techniques in chapter 7. It would make much more sense if you look at chapter 7 first, and then you can go and take all 17 here. Well, no,
Actually, I read the book, and it said we're picking up chapter 7, like, then they introduced other integrals in chapter 6, and they're like, now you know how to do this.
Yeah, exactly.
Like, why do we learn?
So now, what will you do with your web collection? It's not actually an integration technique.
So it's 3 over
Much break
x
manipulation
minus x
to
over
massage the formula into the form where we can actually
And then you square it, and some simplification is just this second. Will just get added. Yeah. Yeah, but then you get to x over 0,
Counter-Strike, you have a crosshair over here. I don't have a crosshair.
Because 1 over x integral is natural log. Yeah. Oh, that's right. Yeah. No, you're right.
All right, let's take a look at this real quick. So integral 1 to 6 square root of 1 plus open parenthesis 3 over x minus x over 12 squared dx. 1 to 6, 1 plus 9 over x squared, and then I have 3 over x minus, sorry, 2 times 3 over x and then x over 12. So you see these guys cancel. 2 times 3 is 6, cancels with 12, you get 2, so it's negative 1/2 in the middle, plus x over 140, x squared over 144 dx. Again, the middle term is 2ab. I'll write it one more time. You write number 2, a is 3 over x, and b is x over 12. 2 times 3 is 6, over 12 gives you 1/2, and then x and x cancel, so your middle term is half. The only way this problem can work is if the middle term is half, negative half, because negative half and right, it's the only way to get the same value back, half and a 1, because 1 is always fixed for the formula. So add these guys together, we get 9 over x squared plus 1/2 plus x squared over 144 dx, and then we use the same trick to compress it back, so it's going to be 3 over x plus x over 12 squared dx. Integral kills the square, and we get to integrate now. We have 3x to the minus 1 plus 1 over 12 x to integrate. Don't forget the parentheses because it's times dx. The integral of, what is the integral here? ln, so 3 ln absolute x plus x squared from 1 to 6. So we have 3 ln 6 plus, that's 6, so I'm just going to write 6 times 6 over 24 because you can cancel rather than multiplying things forever. Well, it's 36 is 3/2, but yeah. Minus 3 ln 1 plus minus 1 over 24. So 3 ln 6, there's nothing you can do about that, so 3 ln 6 stays 3 ln 6. over here is 2/3, right? Because, sorry, 3/2, because you're canceling by 12. So plus 3/2. Ln of 1 is 0, so that term dies, and you have -1/24. Oh yeah, 36, yeah, 35, you're right. 36/24. So the whole thing is 3 ln 6 plus 35/24, and you walk away. That's a number. That's exact number. You can get decimals if that makes you happy. It shouldn't, but let's say it does. That's it. Next class is Monday. The next section is extremely short because it's the same calculation as this. So another 2 sections next class, where we'll spend about 20 minutes on the first section and the rest of the class on the second. Wednesday will be lab time. So get those labs, let's say on Saturday morning, and keep working on it. Do the homework online, obviously, and whatever is open. Any questions? I have office hours, and or shoot the email. Unless it's in a syllabus, then don't shoot the email. All right, well, good night.